Hi everyone, welcome back. This is the last of these three sections that deal with solving word problems using the quadratic equations. So I'll write out a couple of these and just show you how to solve them. And we're going back to some of the problems that involve rate times time equals distance. And as you'll remember, it's really important to solve these by using a chart, a table. Okay, so here's the first problem. Okay, so as always with problems like this, read it a couple of times, make sure you understand the information that's provided, and identify the question. So the question is, how fast did he row? Looks like I left out the question mark. There we go. And so that's what we should use as our variable. So let's let R equal his rate. And then we want to fill in our chart. So the chart will look like this. Here we're going upstream. Here we're going down. Rate times time equals distance. Now, one thing we know right away, excuse me, is that he rode 3 miles up and 3 miles back. Now, we're assuming that he rows at a rate of r miles per hour. Going upstream against the current, he loses 3 miles an hour. The current takes it away. And going downstream, it's added. So, rate times time is distance, which means time is distance over rate. So this time is 3 over r minus 3, and this time is 3 over r plus 3. And what's the information that we know again? The one thing we haven't taken care of is that the total is 1 hour and 20 minutes, which is 1 1/3 hours. So there is the equation that we want. 3 over r minus 3 plus 3 over r plus 3 equals 1 1/3, which is the same as 4/3. So that's the big starting point. And a lot of times if I'm grading a test or a quiz, and let's say a question like this is worth, let's say 5 points, and you get to this point, you've earned at least 3 points by there, because writing down that equation is really the key thing. One of the things that you'll be able to do at some point, if not already, is simply use your Inspire to solve this. So what we have is a equation with rational expressions, and we have to multiply by the lowest common denominator, which in this case would be 3 times r minus 3 times r plus 3. And so if we multiply through by that, what we get is going to be 3 times 3 times r plus 3 plus 3 times 3 times r minus 3, and that equals 4 times r minus 3 times r plus 3. And so you can see from this portion that we're going to have a quadratic. And once again, I'll let you go through the solution of this. One of the intermediate steps that you should get to is right here. You should come down to the equation that 4r squared minus 18r minus 36 is equal to 0. And if we solve that, we get r is equal to minus 3/2, or r is equal to 6. And since we're talking about his rate in terms of miles per hour, it's clear that this isn't true. And so his rate is 6 miles an hour. So there's a problem involving rate times time equals distance, which gives us a quadratic equation. And we've been solving quadratic equations now for a while. Okay, let's try another. So, as always, read this a number of times until you get what's going on. Make sure you identify what the question is, and then assign a variable. So the question is, what is his usual rate? So let's let R equal his usual rate. And now we want to create our chart. So it's going to look something like this. This is what happens if he's late. This is what happens if he's on time. So this is rate times time equals distance. Now, if he's late, he's traveling at his usual rate, which is R. And the distance he's going is 18. So that means the time here is 18 over R. If he's going to be on time, he goes a half a mile an hour faster, which means his rate is R plus 1/2, and the time here will be, because this is 18 over R plus 1/2. So now we have, this is the time that it takes for him to be on time. This is the time which he is late, and so this time is a half an hour more. So to make an equation, I subtract 1/2. And there we go. And again, this is the big, important equation. Once you have an equation, you can actually use technology to solve it. But once again, we note that the LCD is R times R plus 1/2 times 1/2 times 2. Okay, so that is my LCD. And that's what I'm going to multiply everything by. So you can take some time and fill in the missing steps, but the quadratic equation you should come down to is this: 2r squared minus r minus 36 is equal to 0. And we get two solutions. We get r is equal to minus 4.5, and we get r is equal to 4. And you've seen this now a number of times. R can't be negative, so 4 is the correct one. And so his usual rate is 4 miles an hour. And there you go. So that's kind of cool the way that problem works. So now we'll start looking at the last section in Chapter 9, which is all about graphs of the quadratic function. I think you're going to like it. See you then.